Nature in fury. Bizarre phenomena that no one can explain. Have you ever seen water gushing from inside a tree? Or witnessed the sky change color in seconds before an apocalyptic storm? Right now, as you watch this video, inexplicable phenomena are happening around the world, and science doesn't yet have all the answers. Get ready, because what you're about to see will completely change how you view the planet we live on. In this video, you will witness the most bizarre, rare, and terrifying natural events ever captured on camera, from mud volcanoes that erupt out of nowhere to life-changing discoveries. Every second has been carefully selected to show you the raw and unpredictable power of nature, the kind that reminds us how small we are in the face of the forces of our planet. Watching until the end will open your eyes to the hidden reality of Earth, mentally prepare you for the unexpected, and awaken a profound respect for the natural world that you never imagined you had. So press play, leave a like, and let's dive together into these moments that defy all logic. Giant hailstorms. When the sky attacks. Imagine leaving your house on a seemingly normal day. The sun is shining, the sky is blue, everything seems perfect. Suddenly, in a matter of minutes, the scene changes completely. Dark clouds emerge from the horizon as if they were living creatures. The wind begins to howl, and then the unthinkable happens. Hailstones the size of tennis balls begin to fall from the sky with devastating force. This is not a science fiction movie script. This is happening now, in different parts of the world, with increasing frequency. Extreme hailstorms are becoming more intense, more unpredictable, and more destructive. Cars are completely destroyed in minutes. Roofs are perforated as if they were made of paper. Animals are seriously injured, and people have to run desperately for cover. But what really causes these monstrous storms? The answer lies in our planet's unstable atmosphere. When masses of warm, moist air collide with cold air currents at high altitudes, it creates a perfect recipe for chaos. Water droplets are tossed up and down within the storm clouds, freezing and thawing repeatedly, accumulating layers of ice until they become so heavy that gravity pulls them back to Earth at speeds that can exceed 160 kilometers per hour. The scariest part? Meteorologists say these storms are becoming more frequent due to climate change. Global warming is creating more extreme atmospheric conditions, with more energy available in the atmosphere to fuel these catastrophic events. Regions that never experienced severe hail are now facing these storms regularly. Witnesses report the deafening sound these hailstones make when they hit hard surfaces, a noise compared to gunfire or continuous explosions. Entire families take shelter in basements and indoor bathrooms, praying that their homes will withstand the icy bombardment. Farmers watch helplessly as entire crops are destroyed in minutes, representing losses worth millions of dollars. And it doesn't stop there. These giant hailstorms are often accompanied by tornadoes, intense lightning, and flash floods. It's as if nature decides to unleash all its fury at once, reminding humanity that however technologically advanced we may be, we are still vulnerable to the planet's primordial forces. Tornadoes, the serpents of the sky. Now let's talk about one of nature's most terrifying and visually stunning phenomena: tornadoes. These swirling columns of violent air connect the sky to the earth like diabolical umbilical cords, destroying everything in their path with winds that can exceed 480 kilometers per hour. Have you ever stopped to think what it must be like to be face to face with a tornado? Imagine the deafening roar, comparable to the sound of 1,000 freight trains passing by at the same time. The air around you being sucked in with such force that your eardrums burst. Debris flying in all directions, pieces of houses, cars, entire trees spinning in the air like toys. The United States experiences more tornadoes than any other country in the world, averaging over 1,000 per year. There's even a region known as Tornado Alley that runs through the center of the country, where conditions are perfect for the formation of these atmospheric monsters. But tornadoes can and do happen anywhere atmospheric conditions are right. What makes tornadoes particularly frightening is their unpredictability. They can form in minutes, change direction instantly, and their intensity can vary drastically in seconds. A tornado can completely destroy a house while leaving the house next door virtually intact. This randomness creates a primal sense of terror. You simply don't know if you will be spared or devastated. The Fujita Enhanced Scale, used to classify tornadoes, ranges from EF0, winds of 105-137 km/h, to EF5, winds above 322 km/h. An EF5 tornado is capable of tearing entire houses from their foundations, turning them into rubble and scattering debris for kilometers. Vehicles are hurled into the air like projectiles. Centuries-old trees are uprooted. The asphalt of the streets can literally be ripped from the ground. Storm chasers, brave or crazy depending on your point of view, people who pursue tornadoes to study and film them, describe the experience as being in the presence of something divine and demonic at the same time. The mesmerizing beauty of the funnel structure contrasts violently with the absolute destructive power it represents. And here's a fact that will send chills down your spine. Tornadoes can contain multiple smaller vortices spinning inside the main funnel, creating what scientists call multi-vortex tornadoes. This means that within a single tornado, there can be several even more violent mini-tornadoes, each with its own pattern of destruction. It's literally a nightmare within a nightmare. The discovery that changed everything. Oil in Nebraska. Now get ready for a story that seems straight out of a Hollywood movie. Imagine yourself as a simple farmer in Nebraska, working hard every day, tending to the land your family has owned for generations. Life is peaceful, predictable, honest. You wake up to the roosters crowing, work under the scorching sun, and go to bed early to start it all again the next day. Until one day, something extraordinary happens. You're digging a new well, or perhaps repairing a fence, and suddenly you notice something strange in the ground. A dark, viscous liquid begins to bubble from the earth. Your first thought might be one of concern. Is it pollution? Some kind of contamination? But then the realization hits you like a bolt of lightning. This isn't contamination. It's black gold. It's oil. This scenario actually happened on a farm in Nebraska, and it completely transformed the lives of the owners overnight. The unexpected discovery of oil on private land is the modern equivalent of finding a buried treasure chest. And we're not talking about a few barrels. We're talking about potential reserves that could be worth millions, maybe even billions of dollars. But here's where the story gets even more interesting and complex. The discovery of oil isn't just an instant financial blessing. It brings with it a flood of complications, difficult decisions, and profound changes. Suddenly, oil companies are knocking on your door with complex contracts. Lawyers need to be hired. Environmental decisions need to be made. The media might show up. Your quiet private life is turned upside down. There is also the moral and environmental weight to consider. We live in an era where ecological awareness is at its peak. Climate change is an undeniable reality. Fossil fuels are being gradually replaced by renewable energy sources. So, what do you do when you discover oil on your property? Do you extract and profit, potentially contributing to global environmental problems? Or do you leave the oil in the ground, sacrificing a fortune in the name of the environment? The story of this Nebraska farm is a perfect microcosm of the contradictions and complexities of our modern age. It's a reminder that the earth still holds incredible secrets beneath our feet. Vast natural resources lie hidden deep within, waiting to be discovered. And when they are discovered, they have the power to transform lives, communities, and even entire economies. Think about it. While you are reading this text right now, how many unexplored riches are buried beneath the Earth's surface? How many deposits of oil, gold, diamonds, and rare minerals are there, unknown, waiting? And how many lives could be transformed if they were discovered? Eternal fire. Mines that burn for centuries. Prepare to learn about one of the most surreal and terrifying phenomena in geology. Coal mines that catch fire and continue burning for decades or even centuries. Yes, you read that correctly. Centuries. The most famous example is Centralia, Pennsylvania, a town that became a ghost town due to a coal mine fire that started in 1962 and continues to burn to this day. More than 60 years later, the underground fire is still active, and experts estimate it could continue burning for another 250 years or even longer. How is this possible? How can a fire burn for so long without going out? The answer lies in the abundance of fuel and oxygen. Coal mines contain massive amounts of combustible material. When a fire starts, whether through human carelessness, spontaneous combustion, or lightning, it finds a virtually endless supply of fuel. The mine's fissures and tunnels provide enough oxygen to keep the combustion going, but not enough to make the fire burn out quickly. The result? A sluggish underground inferno that can last for centuries. The effects on the surface are terrifying and surreal. The ground is hot to the touch. In some places, too hot to walk on barefoot. Toxic smoke billows from cracks in the ground. Trees and vegetation die in strange patterns, creating death rings in the landscape. Highways develop cracks and sink as the ground beneath them collapses due to the intense heat. On cold winter days, steam rises from the frozen earth, creating a scene worthy of a horror movie. Carbon monoxide and other toxic gases released by these fires pose serious health risks. Residents report dizziness, nausea, and headaches. Children and the elderly are especially vulnerable. In Centralia, the government eventually evacuated the entire city, relocating hundreds of families. Today, only a few stubborn people remain, living literally above hell. But Centralia is not unique. There are hundreds, perhaps thousands, of coal mine fires burning around the world right now. In China, it is estimated that dozens of underground fires consume millions of tons of coal annually. In India, Australia, Indonesia, everywhere there are coal mines, there is the risk of these subterranean infernos. The most disturbing aspect? There's really no good way to put out these fires once they start. Attempts to smother them with earth or flood the mines with water rarely work. The fire simply finds another path, another source of oxygen, another coal seam. It's like trying to extinguish a dragon that lives in the bowels of the earth. Almost impossible. Imagine living in a normal house, on a normal street, knowing that just a few meters below you, a continuously burning inferno exists. That at any moment, the ground beneath your house could collapse. That toxic gases could seep into your basement, that you are literally living on fire. It's a reality that defies comprehension and reminds us that the Earth is far more dangerous and unpredictable than we like to admit. War against invaders. Electric carp. Now let's explore a story that sounds like science fiction but is entirely real. Scientists using electric currents to combat invasive fish that threaten entire ecosystems. Welcome to the bizarre world of modern ecological warfare. Asian carp are considered one of the most destructive invasive species in North America. Originally introduced to control algae and parasites in fish farms and water treatment plants in the 1970s, these carp eventually escaped into natural rivers and lakes, where they multiplied explosively. And when I say explosively, I'm not exaggerating. These carp are eating and breeding machines. A single female can produce over 1 million eggs per year. They consume up to 40% of their body weight in plankton daily, competing directly with native fish for food. In some areas, they can represent up to 90% of the total aquatic biomass. Imagine a lake where, for every native fish, there are 9 invasive carp. The ecosystem simply collapses. But here's the truly bizarre and fascinating part. To prevent these carp from reaching the Great Lakes, one of the world's most important freshwater ecosystems, scientists have implemented underwater electric barriers. That's right, underwater electric fields that electrocute or stun fish that try to pass through. The process is surreal to watch. Boats equipped with electric generators navigate waters infested with carp, releasing pulses of electricity into the water. The fish are instantly stunned by the electric current and float to the surface, where they can be collected. Carp, especially silver carp, have a peculiar behavior when startled. They jump out of the water. So you have absolutely bizarre scenes of hundreds of 10-20 kilogram fish jumping simultaneously, some reaching heights of up to 3 meters, while boats navigate among them. Fishermen and tourists report being struck by these flying carp, resulting in serious injuries. Broken noses, fractured ribs, concussions. These fish are living projectiles weighing over 20 kilograms traveling at high speed. There are viral videos of people being knocked unconscious by jumping carp. It's comical and terrifying at the same time. But the deeper question here is, how did we get to a point where we need to electrify our rivers? The introduction of invasive species is almost always caused by human activity, whether intentional or accidental. And once an invasive species becomes established, it is incredibly difficult, sometimes impossible, to eradicate it completely. This is an ecological battle being fought right now, at this very moment in rivers across North America. Millions of dollars are spent annually trying to control invasive carp populations. Scientists are developing increasingly sophisticated methods, from sound barriers to synthetic pheromones, and even considering the release of genetically modified carp that produce only male offspring, eventually collapsing the population. It's a stark reminder that every action has ecological consequences. That seemingly innocuous decision to introduce some Asian carp to control algae in the 1970s resulted in a decades-long ecological crisis that could cost billions of dollars and have lasting impacts on ecosystems that took thousands of years to evolve. The mystery of the weeping tree, water gushing from the trunk. Here is a phenomenon that seems to defy all the laws of physics and botany. A cut tree from which water gushes continuously, as if it were a natural spring. When you see the images for the first time, your mind simply refuses to believe it. How is it possible? Where does so much water come from? Why doesn't it stop flowing? This phenomenon has been captured on video on several occasions around the world, leaving witnesses perplexed and scientists initially confused. A man cuts down a tree, and instead of finding solid wood or, at best, some damp sap, he finds a veritable geyser of clear water gushing from the trunk with considerable force, filling buckets in minutes. So, what's the explanation? The answer lies in a fascinating botanical phenomenon related to the vascular system of trees and underground water pressures. Trees, especially large species, have incredibly efficient vascular systems that transport water from the roots to the leaves through a process called transpiration. The roots absorb water from the soil, and this water rises through the xylem, conducting vessels, to the leaves, where it evaporates. But here's the crucial part. When a tree has roots that reach a water table or an underground source of pressurized water, it can act as a natural conduit. If that tree is then cut down, especially during the active growing season when transpiration is at its peak, the hydraulic pressure can force the water upwards through the cut trunk. It's essentially like drilling an artesian well. You're releasing water that's under underground pressure. In some documented cases, water continued to flow for hours or even days after the initial cut, gradually draining the underground reservoirs connected to the tree's roots. The volume of water can be astonishing, hundreds or even thousands of liters in extreme cases. This phenomenon is particularly common in areas with groundwater near the surface, saturated soils after heavy rainfall, trees with deep and extensive root systems. Certain tree species are particularly efficient at absorbing and transporting water, but there are also more mysterious cases that don't have simple explanations. Trees in seemingly dry areas that, when cut down, release inexplicable amounts of water. Some speculate about unknown aquifers, unmapped underground water reservoirs, or even unique geological structures that channel water from distant sources. For communities in water-scarce areas, the discovery of one of these water trees could literally be a lifesaver. Traditionally, some indigenous cultures knew of specific trees that could be cut down to access water during times of drought, ancestral knowledge that is being rediscovered and validated by modern science. What's most fascinating is that this reminds us that trees are much more than just static wood. They are dynamic living organisms, deeply connected to the hydrology of the soil, acting as biological pumps that move massive amounts of water from the earth to the atmosphere daily. A single large tree can transpire hundreds of liters of water per day. Entire forests are essentially vertical rivers, moving volumes of water comparable to large rivers, but upwards, from the ground to the air. Mud volcanoes, the earth vomiting. Prepare to discover one of the most bizarre and visually stunning geological phenomena: mud volcanoes. No, we're not talking about conventional volcanoes that spew molten lava. We're talking about structures that eject liquid mud, gases, and sometimes even oil, creating spectacles that are both fascinating and terrifying. Taiwan, among other places in the world, is home to several active mud volcanoes, and when one of them erupts, the result is surreal. Imagine an opening in the earth beginning to bubble, like a giant boiling pot. Then, without warning, an explosion of thick gray mud is launched into the air, sometimes reaching heights of 10 to 20 meters. The mud spreads in all directions, covering everything in its path with a sticky, cold, and dense substance. But what causes these mud volcanoes? The answer lies deep within the earth. In certain geological regions, layers of clay, water, and gases, primarily methane, become trapped under pressure between layers of rock. When sufficient pressure builds up, or when natural or artificial fissures provide an escape route, this mixture is violently forced to the surface. The process is similar to shaking a soda bottle and then opening the cap. The accumulated pressure causes an explosive eruption. In the case of mud volcanoes, the bottle can be kilometers deep, and the pressure may have built up for decades or even centuries. Taiwan is particularly prone to mud volcanoes due to its unique geology. The island is situated in an active subduction zone, where the Philippine tectonic plate is being forced beneath the Eurasian plate. This intense tectonic activity creates the perfect conditions: extreme compression, accumulation of water-rich sediments, and an abundance of natural gases. But mud volcanoes aren't just geological curiosities, they can be extremely dangerous. In 2006, one of the biggest mud volcano disasters in modern history began in Sidoarjo, Indonesia. A massive mud eruption started, possibly triggered by natural gas drilling in the area, and simply didn't stop. To this day, almost 20 years later, the Sidoarjo mud volcano continues to spew tens of thousands of cubic meters of mud every day. The result was catastrophic. 12 villages were completely buried under mud. More than 60,000 people lost their homes. Factories, schools, rice fields, everything disappeared under a sea of gray mud that eventually covered an area of more than 7 square kilometers. The solidified mud created a lunar, alien landscape where vibrant communities once stood. Attempts to stop the flow have all failed. They built giant dikes to contain the mud, but it simply overflows or finds new ways to escape. They tried pumping the mud into the ocean through pipelines, but the volume is simply too great. It's a humbling reminder that when we unleash geological forces, we are often powerless to control them. Mud volcanoes also have another disturbing aspect. They frequently release methane, a potent greenhouse gas. Large eruptions of mud volcanoes can release significant amounts of methane into the atmosphere, contributing to climate change. It's a vicious cycle. Geological activity fuels climate change, which in turn can influence geological patterns. But it's not all negative. Some mud volcanoes have cultural and even touristic significance. In the Caucasus region, mud volcanoes are considered sacred by some local cultures. The mud is rich in minerals and is believed to have therapeutic properties. Spas and resorts have been built around these volcanoes, where tourists pay to cover themselves with the mineral mud and experience mud baths. The invisible power, magnetic fields, and anomalies. Now let's explore something you can't see, hear, or touch. But that's happening all around you right now. Magnetic fields and geomagnetic anomalies. The Earth is essentially a giant magnet, with a magnetic field that extends thousands of kilometers into space, protecting us from deadly solar radiation. But this magnetic field is not constant. It fluctuates, changes, and sometimes creates bizarre anomalies that can affect everything from compasses to modern navigation systems, and possibly even animal and human behavior. There are places in the world where the Earth's magnetic field is dramatically different from normal. The South Atlantic Magnetic Anomaly, for example, is a region where the Earth's magnetic field is significantly weaker. This zone extends over part of South America and the South Atlantic. Satellites that pass through this region experience increased levels of radiation, frequently resulting in malfunctions of computers and sensors. Astronauts on the International Space Station report seeing flashes of light when passing over this region, the effects of radiation on their eyes. Some theories suggest that higher rates of certain types of cancer in regions within this anomaly may be related to increased cosmic radiation penetrating the weakened magnetic field. But there are even stranger phenomena related to Earth's magnetism. Certain locations in the world are known to cause erratic behavior in compasses and navigation instruments. Pilots report disturbing experiences flying over these areas, instruments malfunctioning, compasses spinning wildly, GPS systems losing signal. The Bermuda Triangle, though its reputation is exaggerated by pop culture, does indeed exhibit some genuine magnetic anomalies. Certain areas within this region have unusual magnetic variations that, combined with particular meteorological and oceanographic conditions, can create dangerous situations for navigation. But there is an even more impressive phenomenon related to Earth's magnetic field: solar storm. When the sun releases massive bursts of charged particles, called coronal mass ejections, these particles travel through space and eventually interact with Earth's magnetic field. The result? Geomagnetic storms that can have dramatic effects. The aurora borealis and australis, those dancing curtains of green, purple, and red light in the polar skies, are visible manifestations of these geomagnetic storms. But the effects go far beyond the beautiful visual spectacle. Severe solar storms can to damage or destroy satellites, disrupt radio communications globally, to cause massive power outages, creating electrical currents in oil and gas pipelines, causing corrosion, to affect the navigation systems of aircraft and ships, even inducing currents in electrical networks on the surface. The Carrington event of 1859 was the largest solar storm ever recorded. Auroras were visible as far away as the Caribbean. Telegraph systems, the most advanced electrical technology of the time, failed globally, with operators reporting electric shocks and papers spontaneously catching fire. If a storm of that magnitude were to hit Earth today, with our reliance on electronics and power grids, the result would be catastrophic, possibly trillions of dollars in damage and months or years of disruption. And there is something even deeper and more disturbing. The Earth's magnetic field is weakening. Over the last 200 years, the field has lost approximately 9% of its average global strength. Even more worrying, in certain areas, the weakening is far more dramatic. Why does this matter? Because the magnetic field is our protection against cosmic and solar radiation. If it continues to weaken, or worse, if it enters one of the reversal periods, where the north and south magnetic poles switch places, something that has happened hundreds of times in Earth's geological history, we could face serious consequences. During a magnetic reversal, which can take centuries or millennia to complete, the magnetic field can become extremely weak or even disappear temporarily in certain areas. Imagine a world where parts of the planet are directly exposed to solar radiation. Cancer rates would skyrocket. Electronic systems would constantly fail. Satellites would be destroyed. The ozone layer could be damaged. Genetic mutations would increase. It would be like removing the invisible protective shield that has kept us safe for millions of years. Some scientists speculate that past magnetic reversals may have coincided with mass extinctions. While proving direct causality is difficult, the correlation is unsettling. When Earth's magnetic shield fails, life on the surface becomes vulnerable. And there's another fascinating aspect. Migratory animals like birds, sea turtles, salmon, and even some insects navigate using the Earth's magnetic field. They possess crystalline magnetite in their bodies that acts as a biological compass. If the magnetic field changes or weakens, these animals can become completely disoriented. There is already evidence of this happening. Whales and dolphins stranding en masse on beaches. Some scientists believe that local magnetic anomalies may be confusing their internal navigation systems. Birds migrating in the wrong directions. Sea turtles going to the wrong places. These are small signs, but potentially indicative of larger changes happening in the global magnetic field. Killer waves, giants of the ocean. Let's now head out to the ocean and explore one of the most terrifying and mysterious phenomena of the sea: giant waves, also known as killer waves or monster waves. For decades, sailors have told stories of massive waves appearing out of nowhere, walls of water 20, 25, even 30 meters high, rising in relatively calm seas, capsizing ships and disappearing as quickly as they appeared. Scientists and naval engineers dismissed these stories as exaggerations or marine myths. After all, mathematical models of ocean waves suggested that waves of this magnitude were statistically impossible. They could only happen once every 10,000 years, but the sailors insisted these waves were real, and they were deadly. Then, on January 1st, 1995, something extraordinary happened. The Draupner oil platform in the North Sea was struck by a gigantic wave. But this time it was different. The platform had sophisticated measuring instruments that recorded everything. The wave measured exactly 25.6 meters high, emerging from seas with waves of only 10-12 meters. The evidence was irrefutable. Killer waves were real. Since then, with better measuring instruments and satellites monitoring the oceans, we have discovered that giant waves are much more common than we thought. They occur regularly in all the world's oceans. Estimates suggest that at any given time there may be 10 or more active giant waves in Earth's oceans. But what causes these monstrous waves? The answer is complex and not yet fully understood. Several theories exist. Wave overlap. When multiple waves traveling in slightly different directions meet at the exact time and place, their energies can combine, creating a much larger wave that disappears soon after. Ocean currents. When waves travel against strong currents, they can become compressed, dramatically increasing in height. Nonlinear focusing, a complex phenomenon where the nonlinear physics of waves causes energy to concentrate at a specific point, creating a temporary giant wave. Resonance. Under certain conditions, waves can resonate, amplifying each other exponentially. The result of an encounter with a killer wave is often catastrophic. Large ships, cargo ships, tankers, even cruise ships have been damaged or sunk by these waves. The bridge windows may be 20 meters above the waterline, but a killer wave can hit with enough force to shatter them, flooding the ship's control systems. One of the most dramatic cases was the MS München, a German freighter that mysteriously disappeared in 1978 in the North Atlantic. When parts of the ship were found, the physical evidence showed that something had struck the bridge with tremendous force. The bridge was 20 meters above the water. The conclusion? A killer wave of at least 25-30 meters hit the ship, probably sinking it in minutes. For those aboard a ship, when a killer wave strikes, the experience is terrifying. Witnesses describe a wall of water surging out of nowhere, completely blocking the horizon. There is no time to react. The impact is like hitting a concrete wall at high speed. The force can be enough to shatter steel, destroy cargo containers, and rip entire structures from the deck. And here's the most disturbing aspect. Killer waves can happen in relatively good weather conditions. You might be sailing on a sunny day with swells of 2-3 meters, uncomfortable but generally safe, when suddenly a 20-meter wave appears, strikes, and disappears, without warning. No possibility of preparation. Recent research suggests that climate change may be increasing the frequency and intensity of these waves. Warmer ocean waters mean more energy available. Changing wind patterns create new interactions between waves. Ocean currents are shifting. All of this may be creating more favorable conditions for the formation of killer waves. Imagine being in a small fishing boat or recreational yacht when one of these waves appears. For smaller vessels, there is no possible survival. The wave simply capsizes the boat, breaking it like a toy. Fishermen disappear without a trace. Luxury yachts sink in seconds. Families waiting on land never find out exactly what happened, only that their loved ones never returned. Holes in the ice, deadly frozen lakes. Now let's move on to a completely different but equally dangerous environment, frozen lakes. For those who live in temperate or tropical climates, the idea of completely frozen lakes may seem otherworldly. But in Nordic and high-latitude regions, lakes and rivers freeze solidly every winter, creating seemingly safe surfaces for walking, skating, and even driving vehicles. But here's the problem. Ice is never completely predictable or uniform, and when it fails, the result is often fatal. Falls into icy water are terrifying in ways that few people fully understand. When you fall into water at 0 degrees Celsius or below, several horrific things happen simultaneously. Cold water shock. Your body experiences an involuntary response called the gasp reflex. You automatically inhale deeply, often underwater, filling your lungs with icy water. Many victims drown within the first 60 seconds, even before hypothermia becomes a factor. Hyperventilation. Your body panics, causing you to breathe rapidly and uncontrollably. This makes it nearly impossible to keep your head above water and dramatically increases the risk of inhaling water. Loss of muscle control. Within minutes, your muscles begin to fail. It becomes impossible to swim or even hold on to anything. Your hands become so numb and uncoordinated that you can't grab a rope or pull yourself out. Hypothermia. Your core body temperature begins to drop rapidly. Mental confusion sets in. You may start making irrational decisions, such as undressing, paradoxical undressing, or trying to swim away from help. Death. Depending on the water temperature and the person's physical condition, death can occur in 15 to 45 minutes, often faster. But the truly terrifying aspect of falling through the ice is the entrapment. When you fall through a hole in the ice, the current of the water often pushes you down beneath the frozen surface. You try to swim back to the hole, but you've already lost your bearings. You see light above through the ice, but you can't find the opening. You pound against the solid frozen surface, desperately trying to find the hole through which you fell. There are documented cases of people being found dead just a few meters from the hole they fell into, trapped under the ice, unable to find their way back to the surface. And the problem is getting worse. With climate change, lake ice is becoming thinner and less predictable. Fluctuating temperatures create patchy ice, thick in some places, dangerously thin in others, with no clear visual pattern. What was once reliable knowledge passed down through generations, ice is safe when it's X centimeters thick, is no longer so reliable when temperatures repeatedly fluctuate above and below freezing. In Finland, Sweden, Norway, Canada, and the northern United States, regions where frozen lakes are part of everyday life in winter, there are ongoing educational campaigns about ice safety. Children are taught from a young age never to trust the ice, to always test its thickness, never to go alone, and to always inform someone of their plans. But accidents still happen with frightening regularity. Vehicles tumble through the ice. Cars, snowmobiles, even heavy trucks. Ice fishermen build their huts on seemingly solid surfaces, only to wake up in the morning and find themselves floating on a separate ice island surrounded by open water. Children playing stray too far from the shore and fall into thin areas. Rescue teams have only minutes to act. They use specialized equipment, flotation suits, ropes, weight distributing boards, even hovercraft in some places. But even with a quick response, the fatality rate is high. The icy water kills fast, and the clock starts ticking the second a person falls in. Whirlpools and currents, invisible killers of rivers. Let's now explore aquatic dangers that exist even on hot summer days. Whirlpools and deadly currents in rivers. These phenomena kill hundreds of people annually. Many of them experienced swimmers who simply didn't understand what they were facing until it was too late. Whirlpools, or water vortices, are created when water flowing at high speed encounters obstacles or sudden changes in depth or direction. The result is water swirling in a circular or spiral pattern, pulling everything on the surface downward toward the center. The most dangerous whirlpools occur in rivers just below dams or in areas called recirculating shoals or drowning machines. Here's how they work and why they're so deadly. When water flows over a waterfall or obstacle, it falls with significant force. At the base, this water plunges deep, but then recirculates back to the surface just below the obstacle, creating a continuous circular loop. Anything or anyone caught in this loop is pulled down, pushed downstream, then pulled back to the surface only to be pulled down again. It's an endless cycle, like being trapped in a giant, violent washing machine. What makes this particularly insidious is that, from the surface, These areas often appear relatively calm, just a bit of white foam and choppy water. Inexperienced swimmers see this and think, "That doesn't look bad," and go in. Within seconds, they're trapped. Once caught in one of these rip currents, escape is extremely difficult, even for strong swimmers. You are pulled downwards, battered against rocks or the riverbed, disoriented, unable to determine which direction is up. Your lungs scream for air. You try to swim, but the current is stronger. You break the surface for a second, manage half a breath, and then are pulled downwards again. Rescue teams have a remarkably low success rate in rescuing people from these situations. Entering the water to attempt a rescue only adds another victim. Throwing a rope often doesn't work because the person is being pulled down too quickly to grab it. In many cases, rescue teams can only watch helplessly as someone dies literally meters in front of them. There is also the danger of rip currents, which occur not in rivers but on beaches. These are narrow, fast-flowing currents that flow away from the shore. If you are caught in one, your instinctive reaction, to swim directly back to the beach, is exactly the wrong thing to do. You will be swimming against a current that can flow at 8 km/h or more. Even Olympic swimmers cannot maintain that speed for very long. You become exhausted, panic, and drown just 50 or 100 meters from the beach. The correct technique is to swim parallel to the beach until you get out of the narrow current, then swim back to shore. But in the moment, with waves crashing over your head, water entering your mouth and nose, and fear taking over, this knowledge often slips your mind. Statistics show that rip currents kill more people annually than sharks, jellyfish, and all other marine hazards combined. And most of the victims are middle-aged and elderly adults, not because they are necessarily poor swimmers, but because they overestimate their ability and underestimate the power of the ocean. Sinidoros. When the earth swallows you, imagine driving down a perfectly normal road on a perfectly normal day, when suddenly the ground beneath your car simply disappears. In seconds, you and your vehicle are falling into a hole 10, 20, maybe 30 meters deep. This isn't science fiction. These are sinkholes, and they are real, terrifying, and unpredictable. Sinkholes are depressions or holes in the ground caused by the collapse of the topsoil. They can be small, a few meters in diameter, or massive, swallowing entire houses, city blocks, even sections of highways. And the worst part? They can form in hours or minutes, giving zero warning. The basic mechanism is this. Groundwater slowly dissolves soluble rocks like limestone, creating caves and underground voids. Eventually, the ceiling of these caves becomes so thin that it can no longer support the weight above and collapses catastrophically. The result on the surface is a sudden and devastating hole. Florida is particularly susceptible to sinkholes due to its geology. Most of the state rests on porous limestone. Sinkholes are so common there that there are insurance companies specializing in sinkhole damage. The stories are nightmarish. In 2013, a man in Tampa was sleeping in his bedroom when a sinkhole opened up directly beneath his house. He and his bed were swallowed up in seconds. His brother, in the next room, heard a strange sound and rushed to help, finding only a huge hole where his brother's room had been. The body was never recovered. It was deemed too dangerous to attempt a rescue due to the risk of further collapse. In Guatemala, urban sinkholes have swallowed entire buildings. In 2010, a nearly perfectly circular sinkhole, 20 meters in diameter and 30 meters deep, opened up in the middle of a busy intersection, swallowing an entire 3-story factory. Witnesses said it took only 15 seconds from the first warning sign to the total collapse. China also faces serious problems with sinkholes, particularly in mining areas where underground activities have destabilized the soil. Cars, buses, even construction cranes have been swallowed up. Security camera footage shows people walking normally on a sidewalk when, without warning, they disappear into a hole that opens up beneath their feet. What makes sinkholes particularly terrifying is the complete impossibility of predicting where or when they will appear. There are no reliable warning signs. A geological survey might tell you that an area is at risk of sinkholes, but it can't say exactly where or when. You could be living literally above a cave about to collapse and never know until the moment it happens. In some areas, especially where there is intensive groundwater extraction, the risk of sinkholes is increasing. When pumps extract water from underground aquifers faster than it is naturally replenished, the structural support provided by the water is removed, dramatically increasing the risk of collapse. There are also artificial sinkholes caused by failing infrastructure. Leaking water or sewage pipes can erode the surrounding soil, creating voids. Eventually, the street above collapses. This happens regularly in older cities with deteriorated infrastructure. Drivers report being on the road when suddenly their vehicle falls through the asphalt into a hole filled with sewage water. The experience of falling into a sinkhole varies depending on its size and depth, but it is rarely non-fatal. Falls into deep sinkholes result in fatal impacts. Shallow sinkholes can trap victims in tight spaces from which rescue is difficult or impossible. Sinkholes that fill with water or mud can drown victims before help arrives. Lightning, electric fury of the sky. Let's now explore one of the most visually spectacular and genuinely deadly natural phenomena: lightning. We've all seen lightning, but few truly understand the sheer power and lethality of these natural electrical discharges. A single lightning bolt can contain 1 billion volts of electricity and reach temperatures of 30,000 degrees, 5 times hotter than the surface of the sun. The discharge travels at approximately 1/3 the speed of light. The thunder we hear is literally air being superheated so rapidly that it explodes in a sonic shock wave. Every second, approximately 100 lightning bolts strike the ground somewhere in the world. Every year, lightning kills thousands of people globally and injures tens of thousands more. And most of the victims were doing something seemingly safe when they were struck. Here's a fact that could save your life. If you can hear thunder, you're close enough to be struck by lightning. The 30-30 rule says, when you see lightning, start counting. If you hear thunder before 30 seconds have passed, seek shelter immediately and stay there for at least 30 minutes after the last thunderclap. But many people ignore this rule. The storm seems far away. I just have to finish one more hole of golf. I need to get home. I'm almost at the top of the mountain. These are the last words of many lightning strike victims. Being struck by lightning is an experience that defies description. Survivors report a deafening explosion sound, blinding light, even with eyes closed, a feeling of being on fire, muscles contracting violently, often causing bone fractures, temporary or permanent loss of hearing and vision, severe burns, cardiac arrest, long-lasting neurological damage. Survival statistics are complicated. About 90% of people directly struck by lightning survive the initial impact, but many suffer permanent after-effects: chronic heart problems, brain damage, hearing loss, personality changes, chronic pain, sleep disorders, depression. Many survivors say their lives were never the same again. There is also the phenomenon of blue sky lightning. Lightning strikes that hit the ground far from the main storm, sometimes 15 or even 25 kilometers away, under seemingly clear skies. These are particularly dangerous because the victims have no reason to believe they are in danger. They hear distant thunder, see some clouds on the horizon, but the sky above them is blue. Then, without warning, they are struck. Certain scenarios and locations are especially dangerous. Golf courses, large open expanses where golfers are often the tallest objects, especially if holding metal clubs. Beaches. Water is an excellent conductor of electricity. Lightning that strikes water can travel long distances through the water, electrocuting swimmers. Mountains. High altitudes, especially exposed peaks, are magnets for lightning. Mountaineers are frequently victims. Under trees. Never seek shelter under an isolated tree during a thunderstorm. Trees are frequently struck, and the current can jump from the tree to nearby people. Near metal fences or railings, metal conducts electricity. You don't need to touch the point of impact. The current can travel through the metal and jump to you. And there are even stranger and more terrifying lightning phenomena. Spherical radii, bright balls of light that float through the air during thunderstorms, sometimes entering buildings through windows or doors. They are unexplained by science and incredibly rare, but tens of thousands of sightings have been reported throughout history. Sprites and jets, electrical discharges that occur above storm clouds, reaching the upper atmosphere. They were only recently discovered because they occur so high that they are not visible from the ground. They are massive, they can be 50 kilometers high, and are a reminder that there is much about lightning that we still do not understand. Avalanches, mountains that move. Now let's head to the mountains and explore one of the most devastating and unstoppable phenomena in the alpine environment, avalanches. Imagine millions of tons of snow speeding down the mountain at speeds that can exceed 130 km/h, destroying everything in its path with irresistible force. Avalanches kill more than 150 people annually worldwide, and that number is increasing as more people seek recreation in remote mountain areas. And here's a disturbing fact. In the vast majority of fatal cases involving recreational hikers, it was the victim themselves or someone in their group who triggered the avalanche that killed them. There are several types of avalanches, but the deadliest are slab avalanches. Here's how they work. Layers of snow accumulate on the mountain over time. Under certain conditions, wind, fluctuating temperatures, new snow over old snow, a weak layer can form within the snow structure. Above this weak layer, a denser slab of snow forms. This slab can cover a huge area, the size of several football fields, and be several meters thick. The slab is in precarious balance, held together only by its weak connection to the layer below. Then something breaks that balance, often the weight of a skier or snowboarder. The entire slab fractures instantly, separating from the mountain with a sound that survivors describe as whoomph, or a muffled explosion. Within seconds, the entire snow slab, thousands or millions of tons of snow, is speeding down the mountain, breaking up into ever smaller blocks, creating a cloud of powder snow that can reach supersonic speeds. If you're in the avalanche when it starts, your chances aren't good. The experience is likened to being inside an industrial washing machine filled with wet concrete. You're violently thrown around, slam into rocks and trees, and breathe in powdered snow that fills your lungs. The snow is so dense you can't swim or control your position. You could be buried instantly or carried away by the avalanche for hundreds of meters. When the avalanche finally stops, the snow compacts almost instantly around your body like concrete. You can't move your arms or legs. You might be upside down, unable to tell which direction is up. If the snow covers your face, you have minutes before you die from asphyxiation. Or if you're lucky, you might have a small pocket of air that gives you 15-30 minutes. The weight of the snow above you is crushing, literally. The pressure can be so great that you can't expand your chest to breathe. With each breath you exhale, the snow compacts a little more around you, making the next breath more difficult. It's a slow and terrifying death by progressive asphyxiation. Rescue teams have a critical window of about 15 minutes. After 15 minutes of total burial, the survival rate drops dramatically. After 35 minutes, most victims have already died from asphyxiation. Therefore, the most effective rescue comes from immediate companions who witness the burial and have rescue equipment, probes to locate the victim, shovels to dig, avalanche beacons to transmit location. But even with all the right equipment and training, digging someone out of a deep avalanche burial is grueling work at high altitude. It can take 20-30 minutes of frantic digging to extract someone buried under 1 to 2 meters of compacted snow, time that most victims don't have. There are also even more terrifying avalanches, ice avalanches. When large chunks of glaciers break off and tumble down the slope, they fragment into blocks the size of cars, houses, or even buildings, ricocheting and rolling down the mountain at high speed. There is no survival if you are in their path. See you in the next video, where we'll continue our journey through nature's strangest, most beautiful, and most terrifying corners. Until then, stay safe, stay curious, and never stop marveling. Nature is in a rage, the phenomena are bizarre, and the world is far stranger and more wonderful than you ever imagined. Warm regards, and until the next adventure.